Hello everyone, I am Mrs. Fatima, Assistant Professor in Mathematics, Hindustan College of Engineering and Technology. In this video, we are going to see how to solve Lagrange's linear equation by using the method of multipliers. A linear equation is of the form PP plus QQ is equal to R, where P, Q and R are functions of x, y, z. This is called a Lagrange's linear equation. To solve this equation, first we have to form auxiliary equations dx by p is equal to dy by q is equal to dz by r. Now choose the multipliers L, M, N in such a way that LP plus MQ plus NR is equal to 0. Now take the ratios dx by p is equal to dy by q is equal to dz by r, that is L dx plus m dy plus n dz by LP plus MQ plus NR. As LP plus MQ plus NR is 0, L dx plus m dy plus n dz is equal to 0. Solving this equation, we get the solution. Now let us see this with an example problem. Solve y square plus z square into p minus xy into q plus xz is equal to 0. This equation can be written as y square plus z square into p minus xy into q is equal to minus xz. So this is of the form pp plus qq is equal to r, where p is y square plus z square, q is minus xy and r is minus xz. Now the auxiliary equations are dx by p is equal to dy by q is equal to dz by r, that is dx by y square plus z square is equal to dy by minus xy is equal to dz by minus xz. Already in the previous video we have seen how to solve the Lagrange's linear equation by the method of grouping. Now considering the last two ratios by grouping method, we can solve as dy by minus xy is equal to dz by minus xz. By cancelling minus x in the denominator on both the sides, we get dy by y is equal to dz by z. Integrating, we get log y is equal to log z plus log a. Now bring log z to the other side. So log y minus log z is equal to log a, that is log of y by z is equal to log a. So y by z is a solution. Now choose multipliers x, y, z such that L dx plus m dy plus n dz by LP plus MQ plus NR is x dx plus y dy plus z dz by x into y square plus x into z square minus x into y square minus x into z square, that is the denominator is 0. So consider the numerator x dx plus y dy plus z dz as 0. So integrating, we get integral x dx plus integral y dy plus integral z dz is equal to 0. On integration, we have integral x dx is x square by 2, integral y dy is y square by 2, integral z dz is z square by 2, that is x square by 2 plus y square by 2 plus z square by 2 is equal to a constant. Now cancelling the common denominator, we have x square plus y square plus z square is equal to constant. So the required general solution is phi of c1 comma c2 is equal to 0, that is phi of y by z comma x square plus y square plus z square is equal to 0. Let us see one more example. Solve x into y square minus z square into p plus y into z square minus x square into q is equal to z into x square minus y square. So given equation is of the form pp plus qq is equal to r, where p is x into y square minus z square, q is y into z square minus x square, and r is z into x square minus y square. Now let us form auxiliary equations. Dx by p is equal to dy by q is equal to dz by r. That is dx by x into y square minus z square is equal to dy by y into z square minus x square is equal to dz by z into x square minus y square. Now we have to choose multipliers in such a way that the denominator gets 0. Now choose multipliers x, y, z such that L dx plus m dy plus n dz by Lp plus mq plus nr is x dx plus y dy plus z dz by x square y square minus x square z square plus x y square z square minus y square x square plus x square z square minus z square y square. So all the terms get cancelled in the denominator. Therefore x dx plus y dy plus z dz is equal to 0. On integrating, we have x square by 2 plus y square by 2 plus z square by 2 is equal to constant, that is x square plus y square plus z square is equal to a constant. Now choose another set of multipliers 1 by x, 1 by y, 1 by z in such a way that the denominator gets cancelled. Now see, let L dx plus m dy plus n dz by Lp plus mq plus nr is 1 by x into dx plus 1 by y into dy plus 1 by z into dz by y square minus z square plus z square minus y square plus x square minus y square. So all the terms get cancelled in the denominator. So we have 1 by x into dx plus 1 by y into dy plus 1 by z into dz is equal to 0. On integration, we get log x, that is dx by x is log x. Likewise, log x plus log y plus log z is equal to log constant. Now log x plus log y plus log z is log of x, y, z. So log x, y, z is equal to log constant. On cancelling log on both sides, we have the solution as x, y, z is equal to constant. Now the general solution is phi of c1 comma c2 is equal to 0. That is phi of x square plus y square plus z square comma x, y, z is equal to 0, where phi is an arbitrary function. Hope we understand how to solve Lagrange's linear equation by the method of multipliers. Thank you.